All right, thank you. Welcome. Hello, DevDay. We are the last workshop of the day, but we, of course, the last is always the best. I would also make a call out that after this presentation, we will be having closing remarks from Richard Bear, and I believe we're also having the winner of the scavenger hunt. So please don't take off after this presentation. Stick around for the closing remarks, and hopefully one of you will be a winner. So the last workshop we have for today is all about confidentiality by design. Basically talking about privacy on L1. Maybe to kind of intro this, I think that for many of us who've worked on blockchain, one of the key aspects of blockchain is that it is public, it's trustless, it's auditable, everything, you can see all the different transactions around accounts. And obviously, this new dynamic of privacy is in many ways very counter to that. But, it certainly is a growing need we see, and we see lots of L1s and functionality around blockchains coming up around privacy, because I think we've all recognized that this is a strong and growing need for users of the blockchain. So just a quick agenda. We'll be first talking about what do we mean by privacy. This presentation is going to be focusing specifically on enterprise privacy, and I'll talk about that. Some different overview of privacy approaches, and then Nadine will be taking over with the hands-on approach for this, with some hands-on workshop of how you can bring privacy to Hedera for your own enterprise applications. So I'd like to start by, I think when we say privacy, many people think of different things. And in fact, if you look at, different technologies on blockchains, many of them take different technical approaches about how they approach privacy. So I think it's always good to first ground with what do we mean by privacy? Now, the first thing we could talk about is, I come from the decentralized identity space, is identity privacy. I don't want anyone to know that an account belongs to me. My account on Hedera belongs to Keith Cole. I don't want an association between my account ID or my public key and me as a person. So obviously that's one very important. That's one thing when people think of privacy. That's what they're talking about. Another one, especially as we look towards maybe enterprises or users, is transaction privacy. They don't want to know, I send money to Nadine. They don't want people to know that either my account or her account, they don't want anyone seeing what account did what with what, or what account interacted with a smart contract. They want that all to be hidden. Some other ones, they just maybe look at more amount or value privacy. They're okay with knowing that my account transacted with Nadine's account, but they don't want anyone to know how much or what token. They want all that to be blurred about what was the actual transaction between us. And then finally, I think a growing area is state and data privacy. Often this means not wanting people to know the state of your smart contract. So maybe you could kind of re-engineer about what was happening with the smart contract. But on Hedera, it can mean things you don't want people to see, we have the Hedera consensus service. You don't want people to see whatever you're doing on Hedera consensus service. Or there's many different elements of that. You want to blur whatever state you have on the blockchain. So, there's maybe many more we can add to this, but I think this is a kind of a broad overview of what do we mean when we say privacy. Also, the key thing is, a lot of people when they talk about privacy, they're talking about user privacy. I don't want the government knowing what I am doing on the blockchain or other people. It's what I do on the blockchain is my business. So I think that's certainly one component. Now, we're not going to be covering that much in this presentation today, but obviously that's very important for a lot of people. We're going to be focusing more on enterprise privacy. And I think that there are some very clear, distinct needs around enterprises for privacy. And this is really about that I, as a business, want to use the blockchain. I want all the inherent benefits of the blockchain, but yet I don't want all my competitors knowing everything I am transacting on the blockchain, whether you're doing some sort of a supply management or you're doing stable coins. I want to hide this from public view so I can interact on the blockchain, but yet not let the world know what exactly I'm doing. So with that focus on enterprise privacy, then we can start breaking it down. Even under enterprise privacy, there's many different characteristics. I think one that many people forget about is that where I think enterprise privacy differs a little bit from personal privacy is that personal privacy, I transaction with Nadine, that's it. I don't want anyone to ever know about it. It's done. I think enterprises are a little bit different in that, especially if you're talking about enterprises doing legit business, they do have this auditability component. Yes, I as a business, my business wants to interact with Nadine's business, But if the government or other parties ever come down the line, I do need like an auditability layer so they can say, yes, like I did send X to Nadine, like that is provable in some later audit situations. And that's a very, I think, core and distinct requirement for enterprises that's also kind of difficult to manage as well. Of course, you have the confidentiality and data protection. I don't want I don't want my competitors knowing who I'm transacting with and what I am transacting. And I also don't want my competitors to know the state of my account, for lack of a better word. Often, like when you're talking about privacy on enterprise, often this is like kind of a consortium situation. So, they want to know who it is I'm interacting with. They want to know the identity of the different parties that they're interacting with. They like a KYB layer. They don't want to be interacting with just anonymous parties because, again, they have a responsibility to know who I'm interacting with. Is that person approved? So you have that whole kind of identity layer with enterprise. Governance and policy. So often, again, these are constructs where maybe you want that governance. So again, back to the identity side, I want to be able to say, like, I have a governance layer saying, like, who are the parties allowed to participate in this private network, and what are the governance and rules around that. And also tying to that is, if I'm transacting with Nadine, and then there's a dispute about what happened, or did I really send her 100 tokens, and maybe she says I sent her 95 tokens, well, then you kind of tying back into the auditability, you need mechanisms in place where you could, if I sue Nadine, there's a way to resolve disputes. Again, that requires that in the privacy component that there is this kind of auditability layer, so we can, bring this up in court or resolve a dispute amongst ourselves. And finally, when we're talking about an enterprise system, they want resilience, they want scalability. So, it has to be a robust architecture, especially since, one of the things about privacy, especially if we're going to talk about ZKPs or ZK snarks, this is ever evolving tech. I mean, this tech is rapidly evolving. So I want to make sure I have an architecture in place that's kind of, well, I don't know about future-proof, but certainly it's not going to it's scalable and can move forward without causing too much disruption if the technology underneath the hood changes. So I'll just talk a little bit now about different kind of approaches that the market has taken. Now, some of these are more on the user side, some of these on the enterprise side, and you could probably nitpick about, especially with some of my examples, maybe they don't fit cleanly into these buckets, but I've tried to do the best job I can. So if you take different approaches for privacy, and you can start with obfuscation mixing. I think the famous example of that is Tornado Mixer. Basically, like, you dump a bunch of transactions into a pot, you stir it around, you try to break the unlinkability between transactions, and then you get an output at some later stage, and hopefully nobody can figure out like what A gave to B. I mean, that's the old school way of doing it. It's more statistical than like having cryptographic certainty, but this was certainly an older way, I would say more a legacy way of doing it. Of course, the new way to do it, that's all really hot right now, is ZK snarks, cryptographic privacy, where you can, basically using data sets, you can prove something about a transaction without actually revealing the data values themselves. And this is obviously like very, very much in vogue right now, and is probably the leading edge of tech when people are looking to implement privacy solutions, is around using some form of zero knowledge proof solution. And we have our expert kind of sitting here, Rohit, to keep us honest, and he is our in-house expert on all the ZK snark technologies. You have confidential transactions like Liquid Network or Grin, where really their main focus is not so much about maybe shielding the sender or receiver. They're more just about shielding the transaction values. So it's more like a limited utility for privacy. Something you see really new right now, especially like the Oasis network, is around this trusted execution environment where I can deploy an encrypted smart contract on any network, but then you use this kind of trusted execution layer to actually do the operations of the smart contract. So there's quite a few different examples of that out there right now, but it does require like dedicated hardware or trusted execution environment to execute specifically smart contracts or in the EVM layer. Again, maybe more old school, you had like the permission layers. I think the most famous one of this would be like Corda. Corda always talked about transaction privacy, and this was really because they had a permission network where they didn't allow people to have visibility on what was happening. Fabric has also kind of gone at that as well, and Quorum. These are like permission networks where the privacy comes from that they only allow some people to see the actual network itself. And then finally, I think probably if you look at real life solutions, especially the leading ones, they combine different elements of what I just talked about. They combine ZKP with maybe permission, and you see lots of examples of this. Most recent one would be Jolt ZK EVM, where they've taken a more of a hybrid approach for how they approach their privacy solution. And the other one we'll be talking about Nadine will be presenting is Nightfall, which is again combines different elements off-chain and on-chain for a privacy solution. So what does privacy look like on Hedera? Well, I think it's, we're still looking at the market and the best way to bring privacy for our enterprise users, but certainly something that users can do today. We have Hashsphere and we have a lot of reps here, so this would be the approach that you could have a private network with your partners interacting with it. That's one way to achieve privacy, and that's a very exciting product that we are developing. There's lots of different smart contract solutions out there where you can bring privacy to Hedera, and that's the demo we'll soon be giving, is how you could use Nightfall as one example of how you could bring privacy, very quickly, have a privacy solution on Hedera. And then there's also hybrid, where you can combine something like spheres plus a smart contract solution for a really custom-tailored solution, where you could have a private network with lots of different players, but even within that private network, you can shield interactions from one player to another from other players on that private network. So with that, I'm going to pass it over to Nadine to talk more about what one of these smart contract implementations on Hedera could look like, so you can have privacy for your enterprise.
Awesome. Thanks, Keith. Hi. I'm going to talk to you about Nightfall, and I want to keep this super relaxed because, let's be honest, ZKP can be a bit scary. It's very mathematical. Sometimes people's eyes glance over, so we hope to make this quite interactive and easy to follow. So why Nightfall? Nightfall, as Keith already said, is a really good example of an enterprise solution actually for ZKP. It has actually been developed by Ernst & Young, and Ernst & Young have done this actually on Polygon. So Nightfall enables secure and private transfers, and it does this with ERC20, so fungible tokens, ERC721, so your non-fungible tokens, as well as ERC1155s, so both combined kind of. And it does it with zero knowledge proof and then added scalability through optimistic rollups. Now, with this solution of Nightfall, you can hide who is sending and receiving tokens, how much is being transferred, and also what tokens are being moved exactly. And these are really important things for enterprise clients. Now, what's also really important for enterprises is that while the actual transaction should be confidential, we don't want it to be fully anonymous. And this is where the X509 certificates are coming in. So you need to do some authorization with that. So basically, it's known what identity is on the network, same as, for example, Corda, on what Keith touched on. Now, you can use your own certificate of authority, so it's not prescriptive of which one you should use. So you're kind of free to choose. So benefits, as we already said, private transfers, which everyone wants, and then up to 90% lowered gas fees. Now, it's important to know that, of course, as this has been done with Polygon, and this is 90% lower gas fees to classic EVM tokens. On Hedera, this would have been less anyways. And then also when it comes to the security, we keep the same ABFT security that Hedera already provides. So it's not making it more secure, it's not making it less secure. Perfect use case. So let's briefly talk about the main elements of this solution. Of course, we have layer 1, which is Hedera. And then here as a layer 2, we have the Nightfall layer, which again is our encrypted private layer on top. So in a nutshell, how the solution is working is that we move our tokens from L1, so from Hedera, into L2, so kind of in a private shielded pool. And then everything that is happening on L2 is going to be fully private. So I can transfer with Keith, I can transfer with Alice, Bob, whoever, and that will not be visible. However, when it becomes visible again to the L1 ledger is when I withdraw. So as soon as I move my tokens back from L1 to L2, I will be going public. I hope that this concept makes sense. Now, how this is exactly working is that we have encrypted commitments. Now, these encrypted commitments, just to go back to, for example, the chord analogy that we had before, where you have like states that you can mark as historic. It's taking your transaction and brings them together in a basket, and it says as soon as they are spent, it nullifies them and shows that this has been spent and cannot be used again. Same as kind of Bitcoin's UTXO model, if that makes more sense. Also, what we have is roll-up batches. So we will have this group of commitments with the transactions, and then we roll them up into batches to then submit them. So this is the solution in a very high overview. Next, we can look into who's actually the key player, who is on the network, and who is part of it. One part is, of course, the user. The user wants to make a private transfer. Then what we also have are the proposers. So the proposers batch the transactions into blocks, and then we do have challengers. So proposers batch the transactions, and they do that in a kind of optimistic way. So what they're saying is, until no one challenges me that something is wrong with this block or this transaction, we are going to commit that actually to the ledger. That's the reason why challengers come in. They will verify that really everything's okay, and if they flag a commitment or a transaction to the proposer as being wrong, the proposer loses their stake. So it actually makes the whole solution more secure because it's incentivized to do the proposers to do their job correctly. And then last but not least, we have liquidity providers. Now, in this solution, Nightfall, how it is working is that if you want to withdraw, you have to wait 7 days until you actually can get your money back from the smart contract. Why is that? Because of the challenge period. So that challenging period where the challengers can come in and actually say, hey, something's going wrong. Not everyone wants to wait for 7 days. Depends what you want to have to do with the money, but there is where the liquidity providers step in. The liquidity providers will check if everything's okay. If so, they already pre-fund you the money and then later take your stake. I hope, so far so simple, I hope everyone's following. Everything's better though with the graphic. So this is how the solution kind of looks like on a high level. We do have our decentralized app. Now we have a client, so the user, me, later when I use the app, I'm going to interact with the client. And I'm going to do, let's say, a deposit or transact, anything. That is going to be pushed from the client to the optimist. So the client is actually assembling the ZKP keys, mostly done by the worker who does the heavy lifting. And then it sends it to the optimist. The optimist is bringing all the transactions together and brings it into a block. And then when that's ready to be committed, the optimist moves it to the proposer, who then sends it to L1, which here is Hedera. And now I need to switch my screens, if I can do that. How am I doing it?
Good.
Perfect, thank you. So we are now going to go semi-hands-on. Why semi-hands-on? I only have 30 more minutes. And unfortunately, deploying smart contracts, start getting some Docker images and doing all of that shebang will take a bit longer than 30 minutes. So we are going to not do it exactly from scratch, but I talk you through and I show you the solution. And if you can start already deploying your contracts. By the time I'm finished talking, you should be ready to go. You can find me later on the studio station, and then we can go through it together if you have any questions. But for now, I want to say hello to this beautiful repository, which is the Nightfall version 3 repo on Hedera. Now, this repository has been created, unfortunately, not by me. I wish it was me, but it was Giuseppe Bertone, my colleague. He has taken the original solution, and what he has done is he adapted it for Hedera. As, of course, Hedera is EVM, we didn't have to do so many changes, but we still had to kind of fork it, find the right branch, and do it. Now, first, I realized we missed the slide. Can we go back to the other presentation quickly? Or I can do it here, actually, sorry. This is important. If you want to follow along, you can scan this QR code, or you can just go to github.com, Internet of Peers /nightfall_3 workshop, and then we can follow along. Sorry. But yeah, now let's dive in how to do a very easy deployment of the Nightfall instance, and then do a deposit, transfer, and withdrawal flow, and we see how this is working. So going back to this repository. Again, thanks, Giuseppe, for doing this tutorial. So the README is actually really good. If you follow along, you should be able to just copy and paste the commands and to go from there. What you need is $10 worth of HBAR, so you need the Hedera account. And can be ECDSA keys, ED25519, actually doesn't matter, just sign up on the Hedera portal if you haven't yet. You will also need Docker Compose, and nodes. I usually use NVM as a version manager because it's just the easiest to switch. And then for the browser extension, you either can use MetaMask, or I would highly recommend you to use RabbitWallet. Now, RabbitWallet just has a better UI, and it's also easier to deal with nonces. So if you want to download that now, it's a brilliant time to do so. You just have to, of course, configure it to point to the Hedera testnet. So chain ID 296, symbol, of course, is HBAR, RPC URL 7546, the usual shebang, and you can also put the block node Explorer, which, of course, is Hashscan. Now, for other suggestions, I usually use Visual Studio Code, also for this demo, just for the overview. You also will need to have jQuery installed if you don't already have. And yeah, that's pretty much it. And we can go into the environment variable setup. So if you see here, you will need your native account ID, you will need your EVM account ID. Now, how I usually like to do it is same as Giuseppe, is to just put it into my shell file. So my here it's set as HRC. Why so? You can just use it across multiple repositories, so you do not have to constantly import it as a new file. However, of course, you can do it just as an end file on project base. Then if you go down, you see here the repositories and the command to actually git clone them. So you have two repositories here. One is Nightfall version 3, and the other one is the workshop. What you have to do is you have to go to the Hedera branch. That's very important because Nightfall version 3 actually is discontinued in a way. So there's now Nightfall version 4, which is a bit less stable. And we went from the Aquafix Eve Sepolia branch, which is important to go for because it has a lot of fixes that the main branch doesn't have included. As soon as you have downloaded that repository, now comes the fun part that will take at least 5 minutes, with this internet connection, probably 10. And that is we have to download our Docker images. So as you can see here, we have a client, a deployer, an optimist, the proposer, and it's going just to pull the newest version of the images, and after that, we can move on to the contract deployment. And you see, I'm kind of rushing through the setup steps because really no one wants to see 10 minutes of code in a terminal being deployed. But what I want to point out is these really cool setup scripts that we have here. So if you actually switch to your Nightfall directory, there's a Nightfall_3 workshop directory, which has helper scripts that help you show what your current HBAR balance is without having to log into your wallet, or it also helps you to create a new account. Because for this workshop, we will need 2 accounts. So if you just so far have one, you can just cd into the Nightfall-3 workshop directory, run create account, and what will happen is it gives you a full new EVM address, private key, everything that you need to know. Next, you can just make note of that account and transfer some HBAR into that account, because for the workshop, as we remember, we need $10 in both accounts. If I run the script here, I can see transaction successful. So that means my both accounts now have 100 HBAR, and I can move on. Next step, favorite one ever, JSON RPC relays. We already heard a lot about it today. Why run your own JSON RPC relay? Mostly because of rate limits. If you use Hashio or anything else, you can run into rate limits, and also for logging and debugging. If you use your own JSON RPC relay, you can just click into it, you can see your logs. Your life is so much easier. What you can do, you can check that your environment variables are properly set, so you can cd into Nightfall-3 workshop directory. Again, there's a script for that. And you see everything's properly set. We're ready to go. And then I can run my local JSON RPC relay if I have not already done so. All of this is, of course, also in the README, so it should be pretty easy to follow and self-explanatory. Next step is deploy the contracts. And here again, if you need to check that you have everything environment variable-wise, you can do that. And now in the configurations, we have all already done this for this workshop. So if you clone the repository and follow along, you do not have to worry about configuring your environment variable, your deployment environment variables, because they are already done by us. Of course, if you would want to have it as a productionized solution, you would want to customize these. That's the reason why we flag the files to look into. And then the deployment can happen. If you run the deployer, it should take 10 minutes, maybe 20 here, who knows. And after that, if you go to Docker and volumes, you should see this artifacts and build and proving files directory. Now, you can see here we have the challenges, you have the proposers, the shield contract, which is the most important, and then, of course, the X509 certificates that are in there. Proving file-wise, we have here the powers of Tau. So these are the Romani files. They are coming straight from the Polygon or the Google API store. If you don't trust them, you can create your own ones. It's going to take some time, but I would heavily, heavily recommend just going with the ones that we have in here. And then, next step, very important. In Hedera, of course, we don't really have the concept of a block. So what we want to do here is we want to set the state genesis block, and we want to set it to the current block, because otherwise we're going to go all the way back, and the mirror node doesn't really do anything here that's longer than 7 days. So this is this command here. You can copy it, you can paste it in your terminal, and what you can see here now is it says the current block number, and it will put it for you in your variables file. Again, if you want to look what's in there, you can. They're all in the bin directory. It's all already been pre-configured by us, but you can play around with this. And then when everything is deployed and done, we can remove the orphans, and we can actually start Nightfall, and this is now where it gets fun. So what we're going to do now is we're going to go into the right directory. We have to make sure that we are in Nightfall 3, not the workshop. We want to be in the proper solution. And then we set the version to node version to 18, and we're going to start our Docker containers. And as we can see here, a lot of logs. A lot of logs that are hard to decipher because there's a heartbeat, and I would really recommend to toggle it with just this post request. It's going to make everything a bit more readable. But you know what makes stuff even more readable? Not having it just in one terminal. So the best that we can actually do is open a couple of new terminal ones. And we can do this with these two commands here to only get the logs for the client and the logs for the optimist, which are going to be the most important ones for the demo application that we're going to run in a sec. Now you can all see my very beautiful desktop wallpaper. And me shuffling around some terminals. I hope everyone can kind of see that. So it's just important that you kind of can see, spot what's happening there. At the moment in the client, not so much. Of course, in the Optimist also not. But as soon we're up in the UI, we will see how the transaction moves from client to Optimist and then later to Proposer. Awesome. Next step and last step, start the Proposer. And then we can finally start our demo UI. I'm just doing this in my VS Code. There we go. Of course, I could also do this just in my Docker desktop. I would just constantly have to switch the different logs. So if you want to do it and just follow along, I would highly recommend to do it this way as a setup. And we see here the proposer has been registered in the Optimist. So we get a 200 return from the register endpoint. So our setup is fine and ready to go. And we can finally start a demo UI. Why a demo UI? We all love scripts, but it's just so much easier to follow along and to see some concepts, especially when it comes to users in, or wallet users in L1 and wallet users in L2. So to do this, you can cd into the Nightfall 3 directory and then into demo-ui. And then we're gonna just switching here profiles because separation of concerns. There we go. And then this is our beautiful demo UI. This is very simple. You can now see my Rebbe wallet here on the top, which is the blue bunny, which we're going to look into. And then what we can see here is the wrapped HBAR address. So what we have to deposit actually is wrapped HBAR, not normal HBAR. Now, if you look, I have already set up 2 accounts. One is Dave and one is Carl. And Dave as well as Carl have already wrapped HBARs. If you don't know how to get wrapped HBAR, it's actually super simple. You can just copy that address that you see here on the screen, and you can send the amount of HBARs that you want to have as wrapped HBARs to the contract, and the contract is going to return wrapped HBARs to you. That's this address I'm referring to. So just to show you, I can do 100 HBAR. I've just saved here the contract address. I click send. I sign this transaction, of course. And now I see I have 100 wrapped HBAR more. So more than ready to go. So Carl and Dave are our two personas on L1. So they have our private Hedera keys, and we're now using them to follow along. Whoops. Let's go. Now, what I can do, sorry, I went a bit too quickly. Great. So what I can do now is I can select Carl, and I can create a user on L2. Now, I'm going to, just for the sake of making this concept a bit more clear, I'm going to not name this user Carl. I'm going to name this user Alice. And this user is going to get a mnemonic. You can use your own, or you can just check one here in the UI. And then I click Add User, and I see that Alice is now coming up on the right side of my screen. And you can see that Alice has also this green kind of circle dot, which means that Alice is currently active. I see Alice's L1 balance, and I see Alice's L2 balance. That L2 balance is from some tests before that were still hanging around. And if I see here in the client, I can see that I call the endpoints for commitments, for balance, how it hits the client, and how I create Alice. I can fetch balances if it doesn't do it properly for me. And then I will get that back. And then it goes, as you can see here, to the optimist, who also returns me logs. Now I'm going to do the same thing for Dave. So I'm going to switch to Dave. And now I see Alice is not green anymore because we have that link. And of course, if there would be a productionized setup, we would have a one-to-one mapping, and we wouldn't have both in the same UI. But just for the sake of this workshop, we are doing this. So what we're now doing is we're creating Bob. And we can see that Bob is active on the right side. Again, here on the client, we can see that we have a balance request. And it's really nice to see in the logs how we can follow these transactions. Now, having both of Alice and Bob here as our L2 users, what we have to do is we can deposit some wrapped HBAR that we can actually private transfer with onto the contract. So we are going to do this right now. So I switched back to Alice just because Carl was the first one that I first used. And then I'm going to deposit some wrapped HBAR in the contract. This is 60 wrapped HBAR. This is not some other crazy number. This has 8 zeros because of the decimals that we need. Very important to know. And then I want to talk about that set fee 10. This fee is set by the proposer. The proposer will need that fee. So we always have to think you need to add the fee, or you're going to put like 59.99999 or something. Now I can click deposit, and it wants me to sign the transaction because, of course, we're depositing this into a smart contract. And now I sign, and I can see here on the client already how the transaction hash is coming in. I see the proof, I see the nullifiers, compressed secrets, and I can see the call and a 200 status of the deposit endpoint. It's going to take a while here. but I can see how this has also reached here the optimist. So the transaction handler has received something. And now we can do the same for Dave. This has not reached the proposer yet. This currently is just been doing client to optimist. So if you think I forgot to show the proposer logs, don't worry, we're not that far yet. Same situation here. We're going to put 50 wrapped HBAR. I'm going to add a couple of zeros, and I'm going to add the 10, the fee for the proposer. I'm going to sign this transaction also for my second user, which is Dave. And then again, I see here in the client how it hits there first. It generates the proof, and then it's getting picked up by the optimist. And now we wait, and ta-da. Now I already see people thinking probably, okay, what is now happening with the blocks? We could, of course, make a couple of more transactions to be sure that we create a block. However, we have here this nice cheaty button on the top, which says in nice and green, make block. So we can click that one, and we actually force to produce a new block, which we've been doing just now. So you now see again here we have a commitment here, and then we now see how this is moving. Block proposed is showing up here in the events. This is new, we haven't seen that before. We see the received block numbers, we see the hashes, and then here we see again calling the endpoint for commitments. We go down, and then here in the optimist, we can see it received the block proposed event. So we now have a new block. Oops, being mindful of time, I will have to speed this a bit up. So having the new block now, I can see that my L2 balance has changed. So Alice as well as Bob have new money. Now I can move to the transfer. And for the transfer value, I again can select, where are we? Can select something like 10K, let's say 20 wrapped HBAR. And I can see where I'm currently at. I am Dave. And then Dave is sending this to Alice. And I'm set off-chain. Why did I click off-chain here? Really important. Again, everything that's happening on L2 with these two users is fully private. It is not hitting L1. That's the reason why it is fully private. So all these transfers are instant like this. And also when I click transfer, you can again see how it's hitting the client and then the optimist. But as you have seen, it did not ask me to sign in my Rabbi wallet. It did ask me to sign when I deposited, but not now in the contract. And if I go to my proposer, I see an off-chain transaction call here. I can do this now as many times as I want, and this solution is going to be fully private. Next, let's talk, because I only have a minute left, let's speed up and go to the withdrawals. So if I want to withdraw something, it will, of course, ask me again to sign, because all the withdrawals are going to touch L1. So Rabbi Wallet will come up, Rabbi Wallet will ask me to sign, and again here we can see in the logs, if we follow, how it hits the client, how it hits the optimist, and then the proposer. Now, really important here, the 7 days. We are going to withdraw, and we can see the two balance changes, of course, straight away. But the funds are locked in a contract, and they will only be able to be released after 7 days, after the challenge period is complete. So we don't have in this demo challengers, and we also don't have liquidity providers, just for the sake of time and complexity, but they are in the code. So if you want to download the repository, you can try this out as well and also challenge some of these blocks. In this demo, everything was quite easy. Again, just to wrap up, we set Rabby Wallet up with 2 private keys, so 2 L1 users. Every one of these L1 users was used to create a person on L2. We deposited wrapped HBAR, which we got by sending HBAR to the wrapped HBAR contract to the layer 2. We can do as many transfers as we want on that layer 2. It's going to be private. And the next time when we withdraw, we're going to go back to L1 and we're going to go back to public. I hope this was helpful. I hope that some of you will download the repositories, deploy the contracts, and try a couple of these transfers yourselves. You can also, the contracts are verified also on Hashscan. Unfortunately, I didn't have the time now to show you that. But if you go on Hashscan, you can see the verified contracts. You can see the difference of how a private transaction looks like to a public transaction. If you have any questions, please find me at the studio station later. Talk to me, talk to Keith, or talk to Rohit, who's our ZKP expert. Thank you so much.
Yep, just in conclusion, thank you to Nadine and Giuseppe for that great demo. Again, this is just to give you an idea. I mean, we're not saying you should use Nightfall, but there's many smart contract solutions out there for privacy. This is just an example of one of them if you're looking to implement privacy, and we hope in the future there'll be many more. The main call to action for you guys, we want to hear what your requirements are for privacy, whether it's enterprise or user. Please come find me and Nadine. We'd love to hear your product requirements as a product guy, and we're looking towards the future of privacy on Hedera. So thank you all for attending.